Okay, so guys, question one, there's a few questions that you have to ask or ask yourself for each of these. So the first one, if you guys notice, for A is a quadratic. And how you know it's quadratic is because the highest power is a power of 2. So that one's quadratic. B is linear because the highest power, when you don't see it, is a 1. So x is to the power of 1 even if you don't see that power. And then finally, we have a cubic function, which is to the power of 3. So that's what the degree stands for. It's asking what is the highest power that you see as an exponent. So the highest number that you see. So for A, the degree is actually 2 because it's to the power of 2. For B, the degree is 1 because you don't see it. So whenever you don't see a power with x, that means it's actually 1. And if that's your highest one, there's no other x's, then your degree is 1. And then C, this last one here, 4x cubed minus 2x squared minus 3x minus 10, the degree is the highest number in the exponent, which is a 3. So for C, I'm going to write degree 3. Okay, so that's the first question that you have to ask yourself for each of the graphs that they gave you for question 1. Then they want the domain and range. So this is where I'm going to have to graph each one of these and then look at each one individually. So the hardest ones are quadratics to do the domain and range for. The rest of them are very easy, like the linear and the cubic one. So what I'll start by doing is graphing the quadratic. That's the only one you technically have to really graph, but you do want the picture for each of these. So the first one is 6x squared. And then we have minus 3x minus 2. So our window, I'm going to use the standard window for all of these quadratic functions. That will change when we get to questions 2 and 3, but for these ones, the first question, it should be just the standard window. Graph it, and then that should be your quadratic function. So when you're graphing this, what's important here is you want to find your x-intercepts and you want to find this minimum value, this minimum point on the graph, or it could be a maximum. So this is called your vertex, the lowest or highest point on your graph. So we're going to go second trace. And in this case, when you have a low point, that is called your minimum. So that is number 3. So I'm pressing number 3 for me. Then I'm going to the left side of that minimum, pressing enter. The right side of that minimum value, pressing enter and enter again. And then you should get that the lowest value for me is 0.25 comma negative 2.375. So that is the coordinates of your vertex. So if you took 20-2 or 20-1, that might be something that that you have done, I hope. Okay, so this is, in this case, that's going to help you with your graph because we're going to use that to graph our point, which is about here. And then you're just sketching it, so I'm not going to be too particular as long as you kind of have that minimum value. You can even label it. This is 0.25 comma negative 2.375. So those are the coordinates of that lowest point right there. So that's going to be useful for your domain and range. The domain for all of these graphs here for A, B, and D will be x such that x is an element of real numbers. So the graph is going to continue forever left and forever right. So if you look at the arms, they kind of stretch out and it's like almost a V shape / U, but the arms go forever left, forever right. So that's why we say XER. Our range is why we needed that minimum value. You're going to look at the y coordinate when it comes to the range. And the graph is going to be from that point upwards. You guys see? So if you look at the graph is starting at the lowest point and it's going up from there. So that's the direction it's going. So whenever it's going upwards, you want to say y such that y is greater than or equal to, and then you would put the y coordinate that is the lowest, which is negative 2.375 comma YER. Okay, so you use this symbol when it's upward facing, and then you would use the less than or equal symbol when it's downward facing, a parabola that looks like that. Okay, so those are your two options when it comes to the range of a quadratic function. So that is your domain, your range. They also want the coordinates of your x and y intercept. Your y-intercept, if you guys look at it, this is in standard form. So your constant should always be your y-intercept. So in this case here, we're back. There you go. It was in between my papers. I found it. Okay, so we're on, where are we at? We're at the y-intercept. So the y-intercept, guys, is your constant, which is -2. And then we have our x-intercepts. This is again where I'm going to use my graphing calculator. So to find your x-intercepts, go second trace number 2. So second trace number 2. You're going to go to the left side of one of your x-intercepts, press enter. The right side of your x-intercept by using those arrows. So this is my right bound. Press enter. And for you guys, you're going to have to press enter again. I can't really zoom in, unfortunately. So I'll just show you again that. So left bound, right bound, enter. I get -0.379. So x-intercept equals -0.379. And then you have to repeat those steps again for the right x-intercept. So I'll go second trace again, number 2, left bound, enter, right bound, enter, and enter again, 0.879. Okay, so those are my two x-intercepts that they want. They do want the coordinates. So when it comes to coordinates, you need to write 0, -2 when it comes to your y-intercept. And for your x-intercepts, you need to put the x first, comma 0, and then the other one as well, 0.879, comma 0. So to get full marks, you need to write them as coordinates. End behavior. The end behavior is saying what quadrant does it start in, what quadrant does it end in when you're talking about the ends. So if you guys look, this is quadrant 1 always, this is quadrant 2, quadrant 3, and quadrant 4. So if you guys look, the left end is in quadrant number 2, and the right end is in quadrant number 1. You always go from left to right. So we're going to say that the end behavior is from 2 to 1. Okay, so I'll always go from left to right. So it starts in quadrant 2 and it ends up in quadrant 1 when you follow that curve. So that's what the end behavior looks like. Where are the ends located? Number of turning points is how many maximum and minimum points do you have? This, guys, is a minimum point right there. So this bottom piece right there that I'm trying to highlight in green is a minimum. That is a turning point. So we have one turning point when it comes to quadratics. So one turning point with quadratics. Then they want us to graph it, which we already did. Okay, so that's what they want us to do for each question. So just make sure that you're not missing any of the pieces to get full marks. Question B is a linear one. So again, you want to graph this. So you put -2/3x plus 10 in your calculator. Boy, am I glad I got an extra pen, guys, because I was actually contemplating saying like, no, you know, there's only a few more weeks left, so I don't need one. But today I proved myself right. I needed one. Okay, so that's weird. -2 divided by 3, x squared, or actually it's just x. This is linear. I don't have to put x squared. So it's -2 divided by 3 plus 10 is my linear equation. You can keep the standard window and you can graph this, okay? So you'll actually see that the y-intercept is 10. So if you did want to expand on it, you could. If you want to see more of it, I'm going to change my x max to maybe go to 20. just to see that x-intercept. And instead of stopping at positive 10, we can go up to 15 if we want to see a little bit more of it. So this was my graph once I adjusted the window. So if you do want to see that x and y-intercept a little bit clearly, extend the graph if you have to. Okay, so in this case, we want to go through the y-intercept, which to find your y-intercept, you can also press trace 0, enter, or like I said before, you can just look at the constant. So that constant in this case for the linear one, which I'm graphing y equals negative 2 over 3x plus 10. 10 is my y-intercept. So the coordinates are 0 and 10. So we'll plot that on my graph, and I'll even label that. Actually, I'm going to make it to scale just to be a little bit better at it. So I'm going up by 2, 4, 6, 8, 10. So I'll put this as 10. 0 and 10 are the coordinates of one of my points. And I also need the x-intercept, and that will give me a really clear picture of where my graph is located. So go again to your graphing calculator. You're going to press second trace, number 2 to find your x-intercepts. Go to the left side of your x-intercept, enter. Right side of your x-intercept, enter, and enter again. You should get, it's about 15. So 14.999 rounds to 15, 0. So my x-intercept, there's only one of them, is 15, 0. So 3, I'll go up by 3s here. 3, 6, 9, 12, and 15. Once you have your 2 points labeled, your x and y intercept, all you have to do is draw a line, a straight line, diagonally going through them, and that would be a good graph for your linear polynomial. They also want to know the degree. We already said that the degree was 1, so that was already done. Our next one is our domain. Our domain for all of these guys, A, B, and D, is going to be x such that x is an element of real numbers because it continues forever left and right. Our range is also going to be YER, meaning it can be any real number, but we use the letter Y because it's a range. Then we have the coordinates of the y and x intercept, which we already did. Now we're talking about the end behavior. So the end behavior, if you guys look at the left end is located in quadrant number 2. The right end is actually labeled and located in quadrant number 4. Always go from left to right, so we're going from quadrant 2 to 4. And turning points. When it comes to a linear function, there's no minimum or maximum point, so there are no turning points when we're talking about linear functions. Okay, so that is all the questions that they want us to answer, and we even graphed it as well. Okay, so that's for B. You guys doing okay there? Let me know if you guys need me to slow down or if you need a little bit more clarification as I'm going through the questions. C, question C is a cubic function. So the reason I'm going through all of these is they do have slightly different kind of features, so that's why it's important to kind of review all of those concepts. Our last one is 4x to the power of 3. You're going to use that little house roof. It looks like a kind of like an upwards triangle, so without a bottom piece, so that's the power button. So power of 3. And then minus 2x squared minus 3x minus 10. Graph this function. And again, you might see that a part of the graph is cut off. So in this case, I'm going to change my window to go down to, instead of negative 10, I want it to go lower. So I'm going to decrease it to minus 20. So as you can see, now I see more of the actual cubic image. So this is kind of what a cubic function does. It goes up and then it might come down and then go back up again. Or it might come down, then up, then down again. So it could switch directions depending on what type of graph it is, but this is usually what a cubic function looks like. So what's important to note is the y-intercept. So the y-intercept is that constant value. So when we have our function, I'm just going to rewrite it here. Our degree was 3 because that's the highest power that we see. And our constant is now -10. This is our y-intercept value. So the coordinates are going to be 0 and -10. So we can plot that and put 0 and -10 labeled on our graph. The other thing that's important with our graph is the x-intercept, right? So we want to go second trace, number 2, go to the left bound, which is the left side of that x-intercept, press enter. Right bound, move it above the x-axis in this case, press enter. And then you guys are going to have to press enter again whenever it says the word guess. So the value that you should get for mine is 1.748. So x-intercept 1.748, comma 0. So then you can actually plot that. And then what we're going to do is sketch what we think this looks like. So if you look at your graph, there's a little, it kind of goes upwards a little bit, and then it goes downwards, and then it goes up. So it goes up, down, and then increases. And you should have arrows showing that it continues both upwards and downwards. So the domain for this is just like above. It's going to be XER because it continues left and right forever. And just like a linear function, the range is going to be YER. Because again, it continues upwards and downwards forever as well. So domain just means it goes left and right forever. Range means it goes up and down forever. Then we have our end behavior. This is quadrant number 3. This is quadrant number 1. So the left end is in quadrant 3. The right end of the graph is in quadrant 1. So the end behavior is going to go from 3 to 1. Then we have turning points. If you guys look, there's actually 2 turning points. This is where it changes direction, and this is where it changes direction again. So there's 2 turning points. So that's just how many maximum and minimum points are there, or how many vertexes are there. This one has 2 turning points. Okay, so that is answering, I believe, all the questions. I'm just double checking that I got everything. Yeah. Are there any questions for number 1 before I go on to question 2, guys? Do you have any questions or any clarification about end behavior or degree? Let me know in the chat just by saying yes, no, give me a thumbs up, whatever you think, if you guys need more assistance for those. Are you guys okay? Somebody? Okay. Mara's good. Ailish, are you okay? Perfect. Okay, let's go on to our question number 2. So question number 2, guys, you're going to have to sometimes switch which one is your x and which one is your y coordinate. So in this case, independent variables are always your x's. So in this case, your temperature is actually your x coordinate, and your volume depends on what temperature you're at. So this is your y coordinate. The reason that's important is in the question, sometimes they might say something like, oh, what is the minimum or maximum? Well, that's going to be helpful to know and use the right values. So if they ever want to know what the minimum is or the maximum value, you do need to make sure you label your stuff correctly. Okay, so in this case, temperature, our volume is dependent on what temperature it is. Yeah, okay. Yeah, so they're saying that they're measuring the volume as the temperature increases in this case, so that makes sense. So also, x values are going to be representing L1s, and y is L2. So once they give you a chart, for question 2, they're giving you data, you need to figure out which one should be your x value, which one should be your y value. So that's step 1. Which one's independent, which one is dependent, okay? Now, in this case, you're going to go to your graphing calculator, and I already did that. I already entered the values just to save us some time, but you go to Stat, you go to number 1 where it says Edit, press Enter. And then you're going to enter your L1, which is all your X coordinates, and L2 should be all your Y coordinates. So if you look, my L1s, I can't really zoom in for this, but my L1s are all my temperatures, and my L2s are in this case is my volume. So for you guys, I'm just going to look at your assignment quickly. Yours, a little hint to you is you actually have a choice, guys. So you can choose to have, for question number 2, you can actually choose to have your price of the box be your X and then your box sold Y, or you can have your box sold as X or your price be Y. So it's up to you for how you do it, as long as you're consistent for question number 2. So if you choose your X to be your boxes sold, then every single time they ask for boxes sold, make sure that you're talking about X. So just make sure you know which variable represents what, and use that consistently in every question. So that's just a little hint. You'll get the same answers depending on how you choose it, and I'll give you the proper marks as long as you get the answer that I have at the end. So it will give you the same answer, is what I'm trying to say. Once you have entered your data into L1, L2, then you're going to press Stat. You're going to go to the right where it says Calc. So I'm pressing the arrow until it says Calc. And then I'm going and pressing, in my case, a cubic regression, because it says that it wants it as ax cubed to the power of 3. For you guys, I'm just checking, you should be pressing number 6 on your calculator. So for you guys, number 6. It should say cubic regression at the very top. And then you can keep pressing enter until it calculates it for you. And it should look like something like this. So mine gives me the equation of negative 6.888 e to the negative 5, which means it's scientific notation. So this is what I would write in my answers for question A. So for question A, I'm going to write the equation in the form that they gave you. They said they want the answers to the nearest hundredth. So I'm going to write negative 6.89 times 10 to the negative 5. That's what that E stands for. E to the negative 5 is 10 to the negative 5. Then you're going to write x cubed plus 0.01 when I round to the nearest hundredth, x squared minus 0.06x, and then plus 999.87. So this is my cubic regression. So that's what they want for the first question, is make sure you round to the nearest hundredth, which means 2 decimal places for mine. Now they want us to graph this and answer the following questions. So I'm going to show you how to graph this into your calculator. So you're going to go to your graphing calculator. You're going to press Y equals. You're going to clear whatever is there right now. So clear whatever you got. And for me, you can put it into either Y1, Y2, it doesn't really matter. You're going to press the buttons of VARS, V-A-R-S, VARS. Then you're going to go to, I'm going to tell you what you guys are pressing, number 5, statistics. So you guys are pressing number 5 for statistics. Then you're going to the right until you highlight equation, EQ at the top. And then you're selecting number 1. And what that does is it copies and pastes the equation for you so that you get a really accurate answer without rounding. Okay, so you don't want to round because that will change your answers from what I have. So copy and paste is what I'm trying to show you how to do. Then you're going to go to your window and you're going to adjust your window. Our window, remember, X represents temperature for me. So I'm going to go from the smallest temperature, which was 0 degrees, up to the highest temperature, which was 30. So I'll use my window for now as 0 to 30. My Y's was volume. I'm going to go from 0 volume all the way till it says the highest volume was approximately 1,003.76. So I can go slightly higher to 1,000 and maybe 5 for now. Okay, so I'm just using the chart to figure out what's the smallest to the highest value that I should have for my X and Y. Graph it. And for some reason, it's not helping me out. Okay, I just did in my calculator and it worked. Let me try this. I'll try to show you in my calculator what I'm doing. Okay, so unfortunately, it's not working for some reason. Window. Yeah, that's weird. Okay, so as long as you use the window that they give you, it will graph it for you. I don't know why it's not doing it on this one for some reason. Okay, so with this question here, let me go back here. Find the temperature when the volume is 2000. So I'm just going to do this in my regular calculator because the reliability of this one isn't great. Okay, so if you guys look, I'll just show you. If you guys go to your actual screen here where I am, if you click on it, if you look, I use the same window. I just rounded. I went from 999 to 1005 for my Y min and Y max, and even if I did that on my on the calculator on my iPad, it doesn't work. So for some reason, it's just not helping me. But if you graph it, this one does work here. Okay, so once you graph it, the next step you want to do is you want to find the temperature when the volume is 2000. Okay, so whenever they give you volume, remember volume is my Y value. So you're going to go to Y equals. And for Y2, you're going to put 2000. Okay, so whatever volume they give you, that's my Y coordinate. So I'm putting 2000 into my Y2 value and then graphing it. And what should happen is if I adjust my window to go from maybe 999 to 3000, I'll be able to see more of it, right? So if you guys look, I had to adjust my window to be able to see volume of 2000. So there's 2000. Okay, this is being a pain. Okay, so both calculators aren't helping me here. But another thing you could do, so once you graph it, you want to find the intersection. So you're graphing y1 as the equation that you just got, and y2 should be my value of 2000. Okay, so since this is my y coordinate. So for the first question for B, I'm just making sure that if it's a y value, it goes into y2. Then you're going to press second trace number 5, which is intersection. And then you want to press the intersection button. You want to press enter 3 times. And then press enter times 3. So once you do that, you should find that the answer, like again, I'm going to readjust this. Yeah, mine's not working. Okay, so once you press enter, you should see the value is the x coordinate. So whatever your x answer is, that is the answer that I have right there, okay? For the next one, this is where you want to press trace x equals whatever they're giving you for your x coordinate. Now remember, temperature for me is x, so they're giving us that x is equal to 40 degrees Celsius. So press trace 40 and then press enter. Let me see if this works here. Okay, mine did actually work for this one. So when I pressed trace x equals 40, enter, I got that the y coordinate was about 1009.08, and this is in centimeters cubed. So as you can see from my data, it does make sense, right? Because since we're going higher in temperature, the volume should be higher as well. So just make sure your answers are logical. This one doesn't tell us what to round to, so you can choose what you want to round to there. Okay, so that is for question C. And then the last one is, when will the temperature be 0 degrees? So in this case, you're pressing trace x equals 0 and then pressing enter. So trace 0, enter. I get that the value is 999.89 degrees, or this would be in centimeters cubed as well. So this is the y coordinate. So if they ever give you, in this case, a temperature, put that in for x by going trace, putting it in, enter. And so I did trace x equals 0, enter, and I get the y coordinate, which is the volume when the temperature is 0 degrees Celsius. I wish my calculator was working a little bit better. The only thing I can think of is when I put it in, I actually rounded because I didn't want to have to like recreate the chart, and that's why it wasn't really working for me. But it should work for yours. Let me know. As you're doing question 2, guys, if you're having trouble with the window or seeing your graph, you can always like send me a text and say, hey, this is my window, it wasn't working, and we can work on adjusting it from there. So don't be afraid to ask me if you're having trouble with adjusting your window for question number 2. As long as you can, if they give you a y coordinate, then you want to go to y2 and find the intersection. If they give you an x coordinate, go trace, put that value in, and press enter. So these are the 2 kind of things you need to learn. If they're giving you y, you do this. If they're giving you x, do this, and that's all you have to do to answer questions B, C, and D. Okay, so hopefully that helps you. I know it's harder when I can't really show you it. That's the problem. Question number 3. Okay, guys, question number 3. Any questions so far with question number 2? I know that was a little meh. Sound effects. It's the only way to describe it. You guys okay so far? Ailish is, how are you guys doing? Ailish and Amar, are you guys okay? Ailish is good. Amar, are you okay? Remember, it's okay to not be okay. Okay, perfect. Okay. Okay, so our last question, question number 3, they're going to give you the quadratic regression and they want us to answer a few questions about it. So the first question is, use the quadratic regression to estimate the maximum height of the dolphin during the jump. So we're going to graph this first. Go to your y1, y2, it really doesn't matter which one you place it into. And we're putting in negative 0.746 x squared plus 2.303x, and then plus 2.36, that's an 8, I hope. Let's see, 264. Okay, so for your window, this is a real life scenario with a dolphin here. So with this dolphin, I'm saying what's time? Time is going to be x, so I'm going to go from 0 to Time can go usually, like it's not going to take long for a dolphin to jump in the air, and that's going to be in seconds. So maybe it's going to be 5 seconds, from 0 to 5 seconds for time. And then height that a dolphin can jump at. Well, this one, it's going to go a little below the x-axis because he's going to go underwater. So I'm going to go from -10 up to a height of, let's say, 5, up to a maximum of 5. That's going to be above what I expect the value is going to be. But we just want to go slightly higher than where we think the graph is going to be located. So there you go. There's my quadratic function. And I can clearly see where my x-intercept is, and I can see my y-intercept right there. Okay, so that's something that would be useful, is finding your x-intercept and y-intercept for these situations. So once I have the picture, they want us to find the maximum height. So the maximum height can be calculated by going second trace number 4. Then you're going to go to the left side of that vertex. This is like where I think the vertex is. So you just have to go anywhere to the left of it. So anywhere to the left would be maybe there, or here, or there, as long as you're not on the vertex, okay? So left side of the vertex, enter. Right side of the vertex, enter. And then for you guys, press enter again. The maximum for me is 1.54, comma, 4.14. So then you would write those, you would write the maximum height is the y coordinate, where y is 4.14, and then include the units, which is in meters. So this is the height of the dolphin above the water. Now they're saying determine the height when time is 2 seconds. Time is my x value. So this is similar to question number 2, where you're saying, what are they giving you? Are they giving you x or y? If they give you x, which is 2, then you're going to press trace, x equals 2, and then press enter. And that will give you your answer once you graph it. Okay. So mine, again, like I said, my calculator is not the greatest. I have to always press more buttons or do it differently. So I'm pressing trace, then 2, enter, and you should get that the height is, for me, 3.986 meters. So y equals 3.986 meters, and that's the height when he is 2 seconds into that jump. Okay, so all I did was I pressed trace, x equals 2, enter. Now determine when the dolphin is 1 meter in height. Now they're giving you the y value. So that's why I was telling you before that you need to be consistent. Whatever you label your chart as, whatever your x value is or y value, as long as you're consistent and use that whenever you're labeling something, then you'll get the right answers. So for me, height is my y coordinate. So you can even create a legend to help you out. X for me is time and y is height. So that way you don't forget. So once I know that y is 1, I'm going to go to my graph. I'm going to enter y2 or y3, it doesn't really matter, as my height that I'm trying to see when that occurs. You're going to graph it, and what you should see is that it intersects with the graph that you had originally graphed, which for me is red. You want to find the intersection by going second trace number 5 again. Go as close as you can to the intersection by moving your cursor, and then you want to press enter 3 times. Enter, enter, enter. My. Come on. Okay, so once you press enter 3 times, you'll see that the intersection for me is at 3.596. So you want the x coordinate of that. So 3.596. And this is time, which is in this case, it tells you that time is in seconds, I believe. Yep. Okay, so determine when a dolphin is 1 meter in height. We're saying that that's going to occur at the intersection. So to find the intersection, you would graph it as y2, which was 1. and then you go second trace, number 5, which is the intersection button, and then you're going as close to the intersection as possible and pressing enter 3 times. And that's how you get your solution, which I got as 3.596. So just watch for rounding. If they want you to round to a certain digit, just make sure you include that as well. Question D, state the y-intercept. The y-intercept can be found by pressing trace 0 enter. So trace entering 0 and then pressing enter will give you the y-intercept, which is the y-coordinate of, in my case, 2.364. Now, if your graph is in standard form, meaning that there's no brackets around it, you'll notice that the y-intercept is right there. The y-intercept is already included in the constant. 2.364 is exactly what we got when we graphically did it. So you should see kind of that relationship, and that's how you know you're doing it properly. So with your y-intercept, they actually want you to get a second mark by describing what this represents. This is the height of the dolphin when he started his jump. So it could be that they started calculating his jump when he was already in the air. So he jumped out of water and then he dove back in. So the second he starts diving in, or they're actually saying that the initial height, that's the better way to put it, the initial height of the dolphin is 2.364 meters off the water. And that's really what you just need to include for yours, whatever your situation is. You're just writing that that is the initial height of the dolphin at time equals 0, okay? Find the coordinates of both x-intercepts to the nearest hundredth. Okay, so we want to find the x-intercepts as coordinates. So this is where we're doing the same, using the same buttons we did in the past. So we're going second trace. We're going to go to the first one that I see on my graphing calculator. I'll want to clear whatever I put for my y3. So get rid of any extra stuff that you have and make sure you only have the equation listed as your y1 or y2. So I'm going back to the original graph. And I'm going to actually extend the window so I can see more of the other side of the x-intercept, the other x-intercept, by going into the negatives. Even though time is not allowed to be negative, just for the sake of that question, they do want the coordinates of the x-intercepts. So by extending the window to go from -5 to +5, now I can see both x-intercepts. So you're going to go second trace, number 2, go to the left side of that first x-intercept, press enter, right bound, right side of the x-intercept, enter, and you should get -0.813, comma 0. So don't forget to write it as coordinates for that question. And then same thing for the next one. Repeat the steps by going second trace, number 2, go to the left bound, enter, right bound, enter, and then enter again. You should get that the right x-intercept is 3.9, comma 0. They do want it to the nearest hundredth, so I'm going to add a 0 there for 3.90, and I'm going to round this one to -0.81, comma 0. So this is to the nearest hundredth. So I'm going to highlight these answers because that's properly rounded now. Okay, so watch your rounding is what I'm saying. Now that they have the coordinates of the two x-intercepts, they want us to state what the positive x-intercept represents in this context. So this is where the positive one of 3.90, comma 0, this is when the dolphin lands in the water. So this is how long it's going to take. Time it takes for the dolphin to land in the water. Okay, so that's what they're asking us. What does it represent? So they want us to state what the positive x-intercept represents in this situation. And now they're saying, explain why the negative x-intercept is not valid in the context of this problem. Well, in this case, x represents time. Time is not allowed to be negative, and that's why it doesn't make sense. So when time is negative, it does not exist, so we don't actually use that to explain our problem, or it's not used in the problem. We actually ignore it. So that's like an extraneous solution, a solution that doesn't make sense. Okay, so that is question number 3. So that should have helped you as well because it had the same steps as question number 2. So being able to find the intersection, being able to find the x-intercepts, being able to find out if they give you an x value, or if they give you an x value, what is the corresponding y value, okay? So just like in the previous one, make sure you label what your x and y represent so you know which one to fill in or what steps to do, okay? So the 2 steps you need to remember is if they give you a y, put in y2, find the intersection. If they give you an x, go trace, put in the x value, press enter, and that will give you the answer as the y coordinate. Okay, so that is it. So there's 3 questions you guys have to do for this week. And then just let me know if you guys have any questions about that or if you need help with those items.